Hi, Teresa. Can you hear me? Let me check. Okay. Testing, testing, 1, 2, 3. Well, Teresa, I can see you. That's good. William, can you hear me, Teresa?
Yeah, I can hear you. I'm just trying
Uh,
to figure out how to get. I'm in the room actually, and Babel's in the room too. Do you want us to stay in the room, or
you, as
there's
long
no
as you can
students
get
in the
us.
room except for
Yeah, it's okay for you to stay in the room if that's what you wish, as long as you've got access to a computer and you can join the class through Zoom.
All right, I'm gonna try to put it on this desktop here. The station will be back in a minute.
William, can you hear me? Quinn, can you hear me?
Yeah, I can hear you.
Yeah.
Good, good. We're going to get started shortly. This is, by the way, is a very small class anyway, so don't be too put off by the number you see, although there's only half of you here. Well, good morning, everyone. It doesn't seem to want to go smoothly, this class, but unfortunately my health, I have some issues with my chest right now, so I'm on antibiotics, and it wouldn't be a good idea for me to come. Physically, I'm not up to it, and secondly, I don't want to give you what I've got. So I hope I should be, well, knows when I'm going to be better, but I hope to be better soon. I feel a lot better today than I did yesterday and the day before, so that's a good sign. So I am on the mend. So hopefully it won't be too many days before I can actually get this class underway the way we want it to be. So I've made some changes. The most noticeable change is that the first week being the way it was, I don't think it went too well for a lot of you. I found it difficult to deal with the concepts and the kind of the information the way it's given to you. So I've extended week 1 into week 2. That means there's going to be a lot of work, but at least you've got a little bit more time to work on the first 2 sections from week 1 and hopefully we'll get through the 3 sections from week 2. Second thing is that today I'm going to actually start on basically a summary of all the different techniques. And I'm just going to pick one of my own questions to show you how you would find estimates for the area under a curve for a function using 8 strips. And there are 5 methods that we use in varying degrees of accuracy that allow us to do this job. We have L8, where we use 8 strips, but the left endpoints. R8, same idea, but the right endpoints. M8, where we use the middle of the strip to get the height, and that is the mid-8 point. Then a guy called trapezium, and we use 8 strips, and T8. And last but not least, the most awkward guy, without that extra OS, is Simpson's rule. And we'll do that also with 8 strips. So that's the first thing I'm going to do. I'm going to pick a function. We're going to find the area
Excuse
under the
me,
curve.
can I interrupt?
Go for it.
All right, is it okay if I dismiss Mr. Babel from this room and let him just go to his thing? I'll sit here until
Sure.
the end of the class.
Yes.
All right.
That
And do you
works
want
fine.
to show up another time here?
Say that again,
You wanted
Teresa.
to know, I guess. He wants you to email him and just let him know what to do in the future.
Right. Could you apologise for him? I forgot to tell him that I wasn't coming because I'm ill. And when you're ill here, well,
Yeah, I will.
when I'm ill, it's man flu, so I think I'm dying. So it's hard for me to focus on anything except myself.
All right, that's cool. Thank you.
You're welcome. So the first thing we're going to do then is find all 5 different methods for finding an area under a curve for a function I'll choose. And we'll do the process from start to finish and show you exactly how you should go through it. Because I've been getting emails from the 2 152 classes that I'm teaching that seems to be a problem for some of you. Second thing we're going to do is something I've already done once, but I'll do it again. And that is, how do you use your TI-84 calculator to get the true value for the area under the curve? Because you will need that to do part 3, where there's at least 1, if not 2 questions where they ask you to evaluate the error that you get when you use an approximation. Since these methods don't tell you the exact area under the curve, they tell you good approximations. And typically, these are the worst, and that's the best. And the midpoint is better than a trapezium. So we can put them in order of how well they do the job. And so you might think, well, if this one is the most efficient way, why did we bother doing anything else? Well, there's a good argument for that, but one of the problems with Simpson's 8 is it is very complicated. Whereas something like L8 or R8, or for that matter, T or M, are very easy. So there's a balance between how easy is it to do it compared to how complicated, with how accurate is the answer when you use whatever method you decide. So we're going to do the calculator, we're going to do the error. So the function that I'm going to deal with is going to be 10 over x squared. And we're going to find the area, and it's going to be written something like this: the integral from 1 to 5 of 10 over x squared dx. And that's basically the notation that says that what we're doing here is finding the area under a curve. And the function we're going to do it to is this one. And the rest of it is basically just a notation for how it's written. And we're also going to do it, as you can see here, with 8 strips. And we tend to indicate the number of strips by putting in n equals 8. So what's the first thing I should do in this situation for me, although it's not vital? I would do a sketch. Doesn't need to be particularly accurate, just to get a visualization of what's going on. And you could simply do this by plugging into Desmos and finding out what that looks like. You do it on your TI-84, whatever. And that's going to be my start value 1. And this guy over here is going to be my n value 5. And I'm going to think 2, 3, 4. Now, since I am going to break this into 8 strips, I need to know how wide each strip is, because these formulas use a thing called delta x, and delta x represents the width of one strip. And there is a formula for delta x. If you want to know how wide the strip is, you take b, which is the biggest number, in this case 5. You subtract a, which is the start number, in this case 1, and you divide it by how many strips, in this case, let's just call it n. So that's going to be 5, take away 1, divided by 8, and that gets me 0.5. So I can tell that each one of my strips is 0.5. So, for instance, there's my first strip, there's my second, there's my third, fourth, fifth, sixth, seventh, 8. So if you look at these strips, 1, 2, 3, 4, 5, 6, 7, 8, right? Everything matches. Each one of those strips is the distance from here to here, which if I put this number in, the reason I'm not putting any of the others in is that it's kind of crowded. But if you look there, isn't the distance from 1 to 1.5 0.5? So that's the width of the strip, and we need to know that. So we'll have our function. We'll be told where to start and finish and how many strips to use. And after we've drawn a little picture just to get a visualization of it, we're going to find this first number, delta x, the width. So I'll kind of call that stage 1, right? Step 1. So what do I do in my second step? In step 2, I create a table. So I go x and f of x. And the table, actually I should call them tables, are going to contain the numbers that I need to calculate the strips. So in this case, these numbers along the bottom, the x coordinates, they're the guys that go in my table. So it's going to go 1, 1.5, 2, 2.5, 3, 3.5. Hope I make this. 4. I'll make it. And finally, 4.5. So these are the x coordinates of the positions of where the strips are, right? It starts at 1, then the next finishes at 1.4. The strip starts at 3, and then the other side is 3.5. These are the x coordinates. Now I have a name for them. This guy is called x0. This guy's called x1, x2, x3, x4, x5. Let's see if I got them. 1, 2, 3. Oh, and I forgot. I did run short of room, but I can fix that. There we go. I had to finish at 5, right? There we are. We're fixed now. So that's x6, x7, and finally x8. Now, why it's
I have a
helpful to
question,
have.
right?
Yes.
Oh, I sometimes get confused because I count those up and I go, oh, there's 9 of them when
Correct.
we're only using an n of 8. And so I get confused sometimes. I'm supposed to add the last one to my values.
No, there's always going to be 9 of these, but almost, with exception of S8, almost all of them only use 8 of the 9 numbers. So you don't use all of them when you do L8. You only use 8 of them. And it's the 8 that you use that makes it an L8. to give you an example, if I wanted to use L8, that's the numbers I use in my table. I finish at 7. If I want to do R8, that's the one I ignore. There's my 8 numbers. So any given number of strips, there's only going to be 8 calculations, right? 8 strips we're going to evaluate. And the reason we need 9 numbers is because if they only asked me to do one of these, then I wouldn't need 9 numbers. I'd just write down the 8 I'm going to use. But they don't normally tell you just one question. They tell you lots of them, in which case it's much more helpful just to have the big table and realize that in some cases you don't use the first number, in some cases you don't use the last number.
And then when you're using the midpoint, do you
Yes.
have to go to 5.5? Because if you counted, it would be 1.5 and then 1.
No. Well, so once I finish this one, I will show you the second table, because I did say there's going to be tables.
Okay.
This table, you can use it for left, right, trapezium, and Simpson. Right? This table works with these guys. The midpoint needs its own table.
Okay. Thank you.
Before I do that table, guy, what I'm going to do now is just figure out what the value of the function would be at each of these. So I'm essentially getting the height of these lines here, right? All 9 of them. And I'm going to go to a calculator, and I'm going to show you 2 ways that you can do that. And it really depends on yourself which of the 2 methods I'm going to show you work for you. The first one is you simply do every calculation one at a time. So when x is 1, you would go, well, it's almost pointless, but you'd go 10 divided by 1 squared. And the answer would be 10, so you'd write down 10. It's just fine. That works. Now, the next one would be 10 divided by 1.5 squared. Right, the next value of x was 1.5. And it gets a bit uglier. In this case, 4.4444, lots of 4s. And then you would do 10 over 2 squared, 10 over 3 squared, and that works. You just have to do it 9 separate times. And for a lot of people, that is the easiest way to do it because you don't need to remember how to do something. You all know how to do a calculation. It's a bit boring to do the same type of calculation 9 times, but you can do it. Now, while we're at this, there is an issue with accuracy. I'm not going to do this question to 8 decimal places or even 6 decimal places, which I could. And the reason is just simply time. I don't want to have to write 7 decimal places and calculate with 7 decimal places. And then when I get my final answer, round it off to 6, because it takes too long. So I'm just going to pretend, and I've got perfect power to do this, I'm going to pretend that we were only going to do this estimate to 3 decimal places. So that means that I write down all the numbers I'm going to use to 4. Right? I know the answer has to be 3 decimal places, but always do all the intermediary work to at least 1 more than that. So I'm going to pick 4. And the reason for that is that if you don't, there's some rounding off errors that can happen that will make your answer a tiny bit out, and WebAssign will say you're wrong, even although you're 90% right. Now, I said there's 2 ways to do this. And the second is by doing a table of values, which I find the best way to do it because it's just less work. So you go in here, you press y equals, and you do 10 divided by x squared. That's it. So if the next function is, I don't know, x sine x, then type that in instead. You then do the blue button and you go to table setup. There we go, table setup. The starting value in my table was 1. And the guy they call delta table, think of him as being delta x. So in my case, that's what, 0.5. And that's table setup done. Now, all you need to do now is go blue button, table. And here we go. And there are all the answers that I need and more than I don't need. So the next number would be, what, 2.5. When x is 2.5, the answer is 1.6. When X is 3, it's 1 point lots of ones. When X is 3.5, it's 0.8163. 8163. 3. And the next
Can't see
number.
your page if you're trying to show us your page.
Oh, no. I'd rather keep that and you just hear me, you'll see my page, but you're right. 4, when X is 4, I get what, 0.625. When X is 4.5, I get 0.4. What is it? 4.5 skinny. 4938. 4938. And an extra 3. And lastly, when it is 5, I get 0.4. Okay, so that is the 2 ways in which you can fill up that table. So let's return now and you'll see my filled up table. And it's, yeah, there we go. A bit messy, but it's there. And that's how you create a table of values that you will be able to use for L8, Write 8, T8, and S8. Now there is another special case, which is the midpoint one. So that's going to go here. So here is a table that we would use only for the midpoints. And it's created in a very similar way. Now, this strip starts at 1, and the other end of that strip is 1.5. The midpoint is halfway between those two guys. So the X coordinate would be the one that would be here. Now, 1 to 1.5, if you take the average of them, you get 1.25. Now, the next one is halfway between 1.5 and 1.2, which is 1.75. Now, you could do that calculation all the time, or you could realize that just like here, once you know one X values, don't the others just increase by the value of delta X, which is 0.5. So this one would be 2.25, oops, 2.25, 2.75, 3.25, 3.75, 4.25, 4.75. Now, these guys have names. They have a funny name: X1 bar, X2 bar, X3, X4, X5, X6, X7, and finally X8, X8 bar. Now, do you notice that when you do the midpoint table, you have 8 numbers, and there are only 8 numbers to be used. So I do not keep going. I do not make another guy called X bar 0 or another guy called X bar 9. I do not need them. The only ones I need are the 8 that are here. So 4.75, for instance, would be about here, right in the middle of the last strip. Now, for each of these, I need to calculate its value. So let me zoom back and show you how I can adapt my TI-84 one and just do it basically just do it that way. So I've got Y equals, I've got my table set up. Sorry, my table set up. Oh, get out of there. There we go. Third time lucky. All I need to do in the table setup is to change the one number at the beginning. I don't start at 1. The midpoint started at 1.25. That's the only change. And now I can go second table, and we've got all the numbers we need. So if you bear with me, I'll just be writing these guys down. Actually, I'll switch over. You can maybe see that side of the process. Okay, so that one goes there, 3.2653. Then the next fella is 1.9753. And the next one is 1.3223. And the next one is 0.946. 75. The next one is 7111. And the next one, which is what, 4.25, is 0.55363. And the last one that we need to use is finally going to be 44321. That's a very long, laborious process. Tony, I can hear your, I can hear you, so I'm going to mute you. There we go. So that's a very long, laborious process, and you have to be careful. I almost screwed that up, but I fixed it. And one of these digits, I'm hoping, is exactly as it is. But that is going to be the major chunk of calculator work. So what we need to do is now move over to how do you find these estimates? Well, they all depend on different ways to approach how to do this shape. So here is our basic guy. Here is one. And right, that's what the 8 strips look like. Well, I've not put all the detail in. Now, I would like to be able to estimate the area. Well, one of the things I could do is if you look at just the first strip, I have a choice. Do I use the left hand or the right hand endpoints, right? The 1 or the 1.5 to decide what height to make my rectangle. So when I want to do that, if I choose the left one, these are the rectangles I end up producing. And that we call L8. Left side, 8 strips. Now, if we look at our table, and I'm talking about this table here, where are the heights of these rectangles going to come from? Well, they're going to come from the value of the function at 1, right? And then for the first rectangle, it's going to be 1. For the next rectangle, it's going to be that. What does that end up looking like? Well, it ends up being delta x, the width, times the value of the function at x0, plus delta x, the value of the function at x1. And where do you finish with? You finish at that guy there, who's called x7. So what I've written down is the generic formula for L8. So it's delta x, since that's common to all of them. And you are just going to add up so what does that look like? Well, delta x is 0.5. And then I just add up all of those guys. That's the value f of x0, right? That's the height of the rectangle on the left, the height of the rectangle on the next strip, and all the way to the end. So you add those all up, and you put your answer in here, and then you go 0.5 times that answer. Now, one of the problems I have right now, and I'm going to cheat a lot here, is that I could add them all up, but it would take me too long because I'm going to have to do it 5 times, and that's in itself a bit of a pain. So what I'm going to do is pretend that I added them up, right? And this answer I'm about to write down is not the correct answer. I know that. It's just a guesstimate, right? So can you imagine I really did add these 7 guys up, or 8 guys, I should say, up. And the answer I got was 14, 15, 16, 17, 18, 19, 22. There's. And let's put in some random digits, because that's what you really would get. And so my answer would be 0.5 times that guy. So that would be 11.0617. So let me emphasize that again. This is not the correct answer. This is me did a made up answer to save time. But whatever the correct answer is, you put it in here and you multiply it by 0.5 and you now have L8. So how do you do R8? Well, I can actually keep that picture. Well, you've got the same strips, but you make a different choice. Instead of using the left-hand side to get the correct height of the rectangle, in which case you get that, you use this number first. And so you get that guy. And then the next one, you get that guy. And the next one, and so on. So you choose the right-hand side of the pair. Well, what would that look like in here? Right, there's my first two x's. I use that side, I get an L8. I use this side, I get an R8. So what does the formula look like? It looks like delta x is f of x1, and you finish with f of x8. In other words, you add up those 8 guys. When we did L8, we added up those 8 guys. That's pretty much the only difference. So I know this is 0.5. And let's say I decided to add up, again cheating for time purposes. Let's suppose I added up all those ones, right? 4, 6, 7, 8, 9, 10, 11, 12. Let's say 11.234. Just pretend that was the answer. Then we could divide that by 2 and get 0. What's 0? We could get 5.5323. And that would be how you would calculate the R8. Now, the only thing I've done here that's not perfect is I haven't actually added them up precisely. Can you imagine how long that would take, each one of these? But I did do the process. So whatever the real answer is, you put it here and you'll get L8. Whatever you get by adding these, put it in here and you'll get R8. Now, one of the things you will notice about L8 and R8 is that they will typically be quite different from each other. And if you look at the picture, which is getting a bit messy up here, but when we used the left-hand side, all the rectangles we used were bigger than the area of the curve, which means that this guy is bigger than the true answer. And we call that an overestimate. And that very often happens, not always, but that very often will happen that one of these is an overestimate. If we do these guys, we get an underestimate. And the reason it's an underestimate is that all those rectangles are actually a little bit smaller than the area of the curve. So you can imagine a miniature piece of the curve here, and this is one of the strips. If I use this side, do you see that's bigger than the right answer? And if I use this side, can you see that this area is smaller than the answer? So that's essentially, all of those have the same feature, and that's why we can say overestimate and underestimate. And there very often you get a question that says something like the integral from 1 to 5, 10 over x squared dx, which is the true area. You can say that it's bigger, or I should say less than this side, and smaller than that side. And so even if we don't know the area exactly, we can at least say it's somewhere between 5 and 11. Right, any questions so far? Anybody get any issues? Okay. Let's move on to the third one, which is how do you do a trapezium 8? Now, if you can imagine the same shape as before with all the strips, if you join the start and the finish, you make little funny shapes look like this. That's called a trapezium. What T8 does is it does 8 strips that look like that. So it's not that we use the left side or the right side. In a way, we use both sides to create this shape. And there are going to be 8 strips altogether. Now, there is a formula for calculating T8, which I'm not going to show you, but you can look it up, because there's a different way to get T8. You only need to add these two estimates and half it. So essentially, T8 is the average of an L and a right. So in my case, it was 11.0617 and a 5.5323, all divided by 2. What's that going to get me? 16.03434. Now, I can definitely tell my brain's not working well. Let's do it old-fashioned way. There we go. 040616. There we go. So it's going to be 16.6040 divided by 2, which is what, 8.802. I guess. You know what I can tell you about T8 is, it's a lot easier to do if you already know these two. So if you already know L8 and, well, if you already know L8 and R8, T8 is really a freebie. Now, 2 more to go. The next one is midpoint 8. Now, to get M8, these numbers are going to be used to find the height of the strip, which is these. So it's simply going to be delta x, the value of the function at x1 bar, plus the value of the function at x2 bar, and it's going to finish at the value of the function at x8 bar. So just like in L8 and R8, we use a table and we add up all the function of the value. Those are the numbers, the 8 numbers you would add for L8. These are the 8 numbers for R8. Well, in trapezium, these are the 8 numbers that you're going to get. And again, for time purposes, I'm going to just cheat and pretend I know what they get. 6, 9, 10, 11, 12, 13, 14. I'm going to pretend it's a 14.4214, which ends up being 0.72107. So only one guy left, and that is Simpson 8. And Simpson's 8 is calculated in a totally different way than any of the other ones that we've dealt with. Right? It has its own formula, and it's not a very pretty formula. And so I'm going to see if I can find it for you by going to our ebook, because this is kind of what you should do if you if you get stuck. So here we go. I'm in 152. I'm doing 7-7, and they're talking about Simpson's rule, and I really aren't sure what Simpson's rule looks like. So I'm going to go in here at my ebook. close, hopefully, I'm going to just close that off, guess I can. I'm going to go to 7. Hopefully I'll be able to choose 7, 7 here. There we go. Oh, and you can see they've got the midpoint rule here as well. So I'm going to do approximate integration. A little video you can watch. I'm going to zoom. There's the midpoint. This little picture. Some stuff that we don't need to know right now. This is starting with the Simpsons rule. And zoom back a bit. I think I must have overshot the formula. I've just missed it. Was probably one of these little click things. There we go. Simpsons rule. And it essentially says, if you want to get the area, it's delta x over 3, which is not too weird. Right? Normally we use delta x over 2, but delta x, or delta x I should say. But delta x over 3, and then it gets messy. F of x0, 4 times f of x1, 2 times f of x2, and you continue this 4, 2, 4 pattern to the end. So it's going to be, well, let me show you now. So Simpson's rule is definitely the weirdest one. It's not add up all the numbers, you know, in a column. Right? It's the first function, right? So it's that guy, 4 of this guy, 2 of that guy. Continue the process. 4 of this guy, 2 of this guy, 4 of this guy, 2 of this guy, 4 of this guy, and lastly, 1 of the last guy. Now, very messy, big. The only numbers that you use are the same numbers from this table. Excuse me. So, the estimate for the area is delta x 0.5 divided by 3. One of these guys. Add 4 of these guys, which is too hard for me to do in my head, but this one I'm actually going to do. So you just have to trust me on this one. 4 times 4 point a lot of 4s. And that ends up being 17 point a lot of 7s. And then, so I'll put a little note to self. 1 of these, 4 of these, 2 of these, 4 of these, 2 of these, 4 of these. Did I get that out of sync? I did, didn't I? 1, 4, 2, 4, 2, 4. Oh, I didn't get out of sync. I just lost one, that's all. Times 2, times 4, and finish with 1. Right, so 1 of these, done. 4 of these, done. 2 of these guys, done. 4 of these guys. 2 of these guys. 4 of these guys. Need a calculator. 4 times 0.81632. And that comes out as, here we go, 3.2652. So lost a place here. Got him. Yep, just did him. 2 of these, this guy is 1.25. 4 of this guy is the calculator again. And it ends up being 1.7975. Don't need any more digits for that one. And lastly, one of these guys. So what I now need to do is add these together, which I'm going to do on a calculator. And I'll just show you me doing that on the calculator. And with a bit of luck, we'll be ready. So here goes. So it's 10, add 17, point a lot of sevens. And it's a 5. And then it's a 6.4. And then it's a 2 point lots of 2s. And then it's a 3.26528 plus a 1.25 plus a 1.7975 and finally a 0.4. And that guy, I'll shoot in space. Let's do an entry and see what I did wrong. Okay. All I could have done wrong is put in a plus somewhere more than once. So quick check, 10 is done, 17 was done, 5 was done, 6.4 was done, all the 2s were done. Oh, there we go. You see it right there. After all the 2s, I should have put in an add. There we go. There's the 3.2, the 1.25, 1.79, 0.4. Now we're good. And the answer I got is 48.11277. Now that you saw how much time it took to do one of those, can you see why I had to cheat on the others? So 0.5 delta x divided by 3 times this guy. So 0.5 on my calculator times 48.11277 and divide everything by 3, and the answer we get is 8.0188 because we were doing answers that needed to be to 4 decimal places. So we have T8. Actually, let's put them all down. We found left 8, right 8, T8, midpoint 8, and finally Simpson's 8. And T8 ended up being 8.8020. Is that T8? That was T8, sorry, put it in the wrong place. I am getting tired here. Start again. Left, right, trapezoid, midpoint, and Simpson. L8 was 11.0617. R8 was 5.532. Trapezium 8 That's the 8.8020. The midpoint 8. Must have somewhere around here. Looking. Is up here. 0.72107. And this guy is 8.8018. Well, we have now found 5 different estimates for the area under the curve from 1 to 5 of 10 over x squared. I think the next question you would want to ask yourself is, how accurate are these answers? And which one is more accurate than any of the others? So, first thing we're going to show you is how to get the exact value of this guy. And I'm going to nip over, and it's going to be really quick. I just realized the time, so apologize for that. Here we go. You go y equals, and you put in 10 divided by x squared. You then go to window, and you start at 1, and you finish at 5. You then go to second calc, choose option 7. And the lowest number is 1, and the biggest is 5. And the exact value is 8. Now, if you return to the different estimates that we've got, you can see, just by looking, that that's the best. We're good. 2 decimal places, pretty good. There's an 8 there, I think. Midpoint, trapezium, that guy, and that guy. So we have a term called E for error. And EL is the error that you'd get using this function. And you get that by taking the true value and subtracting your estimate. So in this case, if you're negative 3.0617 out, that's pretty bad. You do an R, same calculation. This time you are positive 2.468. If you do midpoint, real value, take away the estimate, you get 0.72. It's actually negative 0.72107. And if you do, say, a Simpsons 8, you would get and I forgot the trapezium, but they all have the same features, right? And the feature is real value, take away the estimate. So hopefully that's made the process of how to calculate these things. You have to be on top of your game, right? Be accurate, and you should be fine. But I'm going to have to say bye-bye to you lot. So if you can all go, I'm going to have a new bunch of people coming in right away. So we kind of need you to be somewhere else. So bye-bye for now.